This is one of the most common questions that I hear about ChatGPT. When people first learn about it, they hear that controlling ChatGPT are these things called parameters that are able to give it the kind of power that it has. And people say, okay, so what exactly are these parameters and how do they give it this kind of ability? And that is the topic for today, and I intend to demystify that for you. But doing so requires telling a bit of a story about parameters and also known as weights. And the story, like all good story, comes with a beginning and a middle and an end. So let's get started with the beginning. Many stories about GPT begin by talking about machine learning, traditional machine learning that predates GPT. But we're going to go back even further. Our story begins with just simply writing computer programs. A computer program is something which takes inputs and gives outputs by following a series of instructions. And let's come up with a trivial example. Let's talk about a computer program to estimate how much rent might be in an apartment in a particular region. And let's say that we consult with a bunch of experts and they tell us that a good rule of thumb is to take the number of square feet in the apartment and multiply it by 5. Take which floor it's on and multiply that by 20 and add those two things together. And that will give you a good estimate, according to our experts, of the rent of an apartment in a particular neighborhood. And so we could write that program. A developer like me could come along and code that program. It would have some inputs, square feet and floor number, and the output would be the rent prediction. Simple as that. Everyone knows this stuff. So now let's talk about machine learning for 1 second. So machine learning came along, and it is, of course, the field of achieving a task not by explicitly programming how to do that task, but rather by learning from data how to do it. So what does that mean? To make that concrete, let's go to our example of the rent. So it works by coming up with a hypothesis for what calculating rent might look like, building a model for that hypothesis, and then training that model from data. So, very simple hypothesis would be that rent depends only on the number of square feet and what floor it's on. That'll be a simple hypothesis. And then our model might be, let's say, okay, let's take a quantity A. We'll take A multiplied by the square feet, and we'll take B multiplied by the floor number, and we will add those things up to give us the rent, where A and B are still to be set. And so how do we set A and B? Well, of course, we do it with data. It's as simple as that. There are these two phases of working with machine learning. The first phase, called training, is when you look at lots of examples, in this case, lots of examples of apartments, how much it costs to rent them, how many square feet are they, what floor are they on, and you use all of these examples to figure out how can we set A and B the best so we get the best possible outcomes when we look across all of our training data. And of course, there are very simple ways of doing it, and basic statistics, you sort of take an average of the weights and all that. Or there are some more clever ways of doing it that look for trends, maybe throw out outliers that might have a different explanation, and that arrives at a better model for predicting prices. But at the end of the day, that's all that it involves. It just involves coming up with a way to set A and B. And once you've done that, once you've determined A and B, you then move to the next phase, which is known as inference. And during inference, you no longer change A and B, they are now fixed, and you now use this model as a way to predict the rent of new apartments that you didn't see while you were training, something new. And if you've done a good job, then you are accurate in your predictions. And that, of course, is all there is to traditional machine learning, as you probably already know this, and it's probably no surprise at all to know that A and B are what we call parameters or weights. I think I already used the word weights. But these are the parameters of the model. And of course, in practice, you probably have many more than that. Apartment prices probably depend on a few more things. So you might have C, D, and E, and you don't necessarily just multiply and add. You might try out all sorts of different models of different ways to combine these things. And a typical machine learning model might have anywhere from 20 to 200 of these kinds of parameters controlling how it makes its prediction. And so that is the end of the beginning of our story. And we're now moving on to the middle. So I'm now going to introduce an analogy, which I'm going to stick with for the rest of this story. So you have to get used to it. You might get quite bored of it. But let's think of this model with these two parameters, A and B, that control how the square feet and floor number contributes to the output. Think of it a bit like a sound mixer. I mean something like this. the kind of thing you see in a music studio when you have like a band with different instruments and there's some sound engineer that's able to blend the 4 instruments that they're listening to create the perfect output. That's very similar to this idea of blending 4 different features to try and come up with some prediction. So let's think of it that way. During training time, that's like the band is rehearsing, the sound engineer is sitting there listening, and based on what they're hearing, they're tweaking these parameters until the sound they're hearing is just what they're after. And then once rehearsal is done, they take their hands off the mixing board, it's done, training is over. We now move to inference. The band performs or they record their music. You're not touching the mixing board anymore. You've got it just right, and the music is perfect. So that's the analogy. Well, modern AI involves chaining together many mixers like that. And let me explain what I mean. I should first point out that while we call this modern AI, this has been around for a long time. This was invented in the 1950s. It was very successful to start with, and then it sort of went dormant for a bit, and now it's having a resurgence. But this is the idea. Let's suppose that we have a mixer that's allowing us to mix 4 different band members from our band. And then we have a second mixer that is also mixing those 4 different band members. And then a third mixer and a fourth mixer. All these 4 mixers are allowing us to take a slightly different look at the 4 musicians. And we take the outputs from each of these mixers and we put those 4 outputs into another mixer. A mixer which is mixing these 4 mixers. It's a mixer of mixers. And then we do that again with a second one that's taking a different cut of these 4 mixers, and a third and a fourth. And you know where I'm going with this. You then do it again. You take a mixer, which is mixing the mixer, which is mixing the mixers, which is mixing the original artists. It's a mixer of mixers. That is the idea behind layering these mixers one after another into a sort of stack, a set of layers of different mixers. These things are called neural networks. And the reason they're called neural networks is by a sort of analogy with the human mind. This whole idea was originally inspired by thinking about a human neuron. The idea is you've got a neuron, like a mixer, which takes some kind of blend of the different synaptic connections that it has from other neurons, and it mixes them up, and out comes some kind of output in the form of whether the neuron fires or not. And in fact, that does bring up a good point. With these mixers, we don't actually just take a sort of blend of the music. We also distort the output in some way, a bit like the way a neuron either fires or doesn't fire. We do something that slightly messes around with what comes out of the output. And we do that so that each mixer makes its own unique contribution to the overall information that flows through all of these mixers. Because if you didn't do that, if it were literally just 4 sliders controlling the different volumes of 4 inputs, then in fact, no matter how many mixers you had, you could replace all of them with just one mixer. Because at the end of the day, all you're ever doing is just varying the 4 volumes of the 4 original artists. So for that reason, there is this sort of change introduced in front of each of these mixers. And technically, the people call that the nonlinearity, or also known as the activation function. But this is something which slightly changes what comes out of each mixer so that each one has its own unique role to play in the overall flow of information. So there's a bunch of other clever tricks that are used to make this work really well, but they're not important for the overall story. You've really got the basic idea when you think of this just as a set of mixers that are all hooked up to each other. One of the quite important tricks is the way that these sliders, these parameters, are changed. There's a clever trick for getting the output, deciding how close is that to what you wanted, and then being able to just nudge each of the different sliders across this network of mixers so that next time, if you have exactly the same input, you'll do slightly better with the output. And this trick to being able to do this really quite nicely so that you sort of gradually learn different patterns in the inputs and get better and better at predicting the right output. That trick is part of the sort of secret sauce of what makes these neural networks work really well. But there's nothing particularly sophisticated to it. It just happens to work quite well. And at the end of the day, it's just about shifting around these parameters so that you get a little bit better at selecting the right output. And so at the end of the day, you've got training and inference, just as we did in the prior example. During training, you're listening, you're looking at the outputs, and you're tweaking all of the parameters on all of these different mixes so that you get that much better at predicting the right output. And once you've done that, you take a step back, you freeze all of these parameters, you stop changing any of the sliders in your mixers, and now you bring in new inputs, you let it flow through the mixers, and out comes an output. And that is inference. And that is how modern AI works. And now I'm just going to put up one more time a picture of a mixer so that you can have another quick moment of inspiration and see how simple it is to think of this as just blending inputs to give an output like that. And we are now moving into the end of the story. So a large language model like ChatGPT uses exactly this setup. Mixers layered on top of mixers. There are a few ways in which it's a bit different. One of them is that it is what's known as generative, and that's just talking about what kinds of inputs and outputs there are to this model. The inputs is a bunch of text, which we sometimes call the prompt. It's a bit of text that we're expecting some kind of response to. And the output is just the next piece of text that is expected to follow the input prompt. And this text is actually chunked into a group of a few characters at a time that's called a token. And it just turns out we do that because it works quite efficiently that way. We didn't need to do it that way. It could be one letter at a time, it could be one word at a time, but doing it as little groups of letters turned out to work really well. So that's how it's done. Groups of letters are passed in, and what comes out of the other side is the prediction for the most likely next token to follow this set of tokens that were in the input. So another thing about it is it's what's called pre-trained, which means that the whole model has been trained with lots and lots and lots of data. It's been trained with all of the data on the internet and a whole lot more data than that as well. And the idea is that you take a bunch of data. Let me give you an example. You take something like a Wikipedia page, and let's say halfway on the Wikipedia page it says something like, the capital of France is, and then the next word is, of course, Paris. What happens is, as you're feeding this into the model, you take the input as the capital of France is, and you feed that into the input, and you see what comes out as the output of the current model as you have it. And of course, you're hoping that the word Paris comes out. But if it doesn't come out, if the wrong word comes out that doesn't match what was in your training data, then you then do this process of slightly nudging all of the parameters, all of the sliders on your mixing boards in this big setup, so that next time, if it gets the input, the capital of France is, it's slightly more likely to come up with the word Paris. You don't set it so it will definitely identically get the word Paris, because you're just trying to teach this big set of parameters to detect patterns in the inputs and use that to generate the most likely word that will come next. And the final thing to mention about these models, these large language models, is that they use a particular approach for hooking up the different mixers to each other. And that approach goes by this technical name transformer. That sounds super high-tech and sci-fi, but it is in fact just a particular methodology, a particular way for which mixers get connected to which mixers and how they're all arranged. It was invented by Google in 2017, and it is at the heart of almost all the modern models, these large language models. But interestingly, we don't actually think that there's anything fundamental about the transformer that means that we need to use it. It just happens to work really well and be really efficient. So if we hadn't invented the transformer back then, we probably would still be getting to capabilities like GPT's capabilities. It might just have taken us a bit longer to get there. The transformer gave us this big head start. It accelerated the progress that we were making with these kinds of models. But otherwise, there's nothing particularly fundamental about it. And because it's an approach, it's an arrangement for how you hook up these different mixers, from our analogy, or how you connect these neurons, to use the proper term, it's known as an architecture, and people call it a neural network architecture. It's a particular way to organize your neural network. And you probably see where I'm going with this. If you look at the three sections on this slide, you'll see that the first one starts with a G, and the second one starts with a P, and the third one starts with a T, because of course this is what ChatGPT actually is. GPT is a generative, pre-trained transformer. But there's something a bit surprising that you need to wrap your head around now. You remember originally we talked about these models, so we gave an example model that had two sliders, two parameters, A and B. It was for the square feet and the floor number of the apartment. Imagine now, though, that you don't have a mixer with two sliders, A and B, but rather you have a mixer in front of you with 100 sliders, 100 different parameters that you can change to craft the perfect algorithm or the perfect music that you're listening to as you blend these different instruments. 100 sliders, that's a lot, and they're all in front of you. And now imagine that we take this mixer with 100 sliders, all of these parameters, and we hook it up to another one and another one. So we're getting hundreds of these different sliders contributing to how the output is generated from the inputs. And now I want you to imagine that every single human on the planet, every person, has a mixer with 100 parameters. Every single person has got one of these, and they're all arranged in this clever way, this transformer architecture. They're hooked up to be very efficient so that information can flow through every single person's mixer on the planet. Imagine that. That is the complexity. That is the number of parameters in ChatGPT. Except it's not. That's not true. I'm lying to you. The truth is that ChatGPT has 10 times that number of parameters. It is like having 10 times the number of people on the planet, each with their own mixer with 100 sliders, or it's like 10 Earths or something like that. It's so much. It's so much. It is just bewildering. So I hope that story gives you some kind of sense, some intuition for how much information there is baked within ChatGPT. So many trillions of these parameters. That's at the heart of ChatGPT. The bottom line is that ChatGPT is something of a conjuring trick. It's deceit. At the end of the day, the model, the ChatGPT model, is just really good at predicting the next token that should come after some input. It really is what some people describe as predictive text on steroids. It's really very effective at it. So much so that it gives us this impression that there's some intelligence happening, that there's some understanding of the meaning behind the concepts that it's discussing. And then there are a couple of clever little tricks in there to make it all the more convincing, to fool us even more. For example, the way it works is that it doesn't predict a whole paragraph of text the way you might think, but rather it gets an input prompt and it predicts just the very next token and only the next token, a bit like the first word. And then the original input is fed in with that word that it just predicted, and it then predicts the next word to come after this. And that repeats. And that's why when you're using ChatGPT, you see the familiar typewriter animation, because it's actually generating token by token. And each time the whole stuff so far is passed in to generate the next token. And somehow that just works really well at giving this sense that reasoning is happening and that things are being thought through by the model. But it's just a byproduct of it being really good at predicting the most likely next word to follow this set of words. And there's another similar trick that's used to give us the impression that it has a memory. ChatGPT has no memory. If you've been talking for a few minutes about somebody and you refer to them, it appears to remember them and you can continue the conversation. But that is a clever illusion. What's going on is that every single time you press enter and send a message to ChatGPT, it doesn't just send it that little message you just written. It sends the whole conversation so far, including what you just wrote. And it's predicting the most likely next tokens to come next. And so if you refer to somebody and then you refer to them again later, it's going to see the connection between that information in the input, and it will predict a next token consistent with that relationship. And that gives us this illusion of memory. People, when they first hear this, first of all, are are surprised and often don't believe me. And then they say, all right, but I still don't understand. How could it possibly solve science problems at PhD level? Physics, chemistry, biology, PhD level, if all it's doing is statistically most likely next token. That just doesn't make any sense. And the bottom line is, it's super hard to fathom this, to almost to believe it, but that is all it is. That is the truth. It turns out that a byproduct of really great next token prediction is this ability to reason things through and to solve PhD level science questions and write computer code and lots of other things. It is just a byproduct, a factor of all of these parameters. And people call it emergent intelligence. It's this property that with enough information, with enough of these sliders, connected to more sliders, connected to more sliders, this effect, this result, is that it appears to be exhibiting true intelligence, but it's just a byproduct of really good next token prediction. And that completes my explanation. I hope you now have some intuition for what a parameter is, and I hope, like me, you now have some sense of how these parameters work and how it is that based on these parameters, ChatGPT is able to generate the kind of output it does. At least, if you're anything like me, you now fully understand how it works, but it's probably still a bit of a mystery to you how it works so very well.